Hello and welcome to my YouTube channel. Today we're talking about differentiator operational amplifier, or commonly referred to as a differentiator. And when it comes to this type of operational amplifier, it's also been designed out of our understanding of inverting operational amplifier, how an inverting operational amplifier works. Right? So you can see that it's just similar to an inverting operational amplifier. The difference is that here we used to have a resistor there, right? Referred to as the input resistance. So you can see that we replace that resistor by a capacitor. So we have C in, meaning the input capacitance that we have there. Now, once we've done this, we just repeat all the process again. Again, V1 here is grounded. That means V2 is also to be grounded as well because of virtual ground. So we have the voltage at node A here, because you can see that we have a junction, because we have a connection of 2 or 3 components. Then you can see the voltage at node A is the same as that of the V2, because V2 you can see is connected to the inverting terminal, and then the voltage at VA becomes the same as that of V2, and that is also going to be 0 as well. Then we can here apply the Kirchhoff's current law at node A, and in doing so, we get this equation, right? So you can see there we have at this node IN is the only one entering the node, right? Entering node A. Then we have also, let me indicate this I, and I, and then IF are leaving the node. So we have sum of current entering should be equal to sum of current leaving. So we have I in the plus I plus IF, which is the feedback current. Now I in here, I is going to be 0. Why? Because we think about an operational amplifier having an infinite input resistance. So as a result of that, I mean the current input into the operation, which is I, that's the current engine operation, is 0. And as a result of that, we have I in being equals to IF. Then again, we come here, apply our notion of potential difference. So if I have I in is starting from V in, and then arrives at node A, then the voltage difference or potential difference is going to equal to V in minus VA. But here you can see here we have a capacitor, and when it comes to the capacitor, the current passing through a capacitor, we can have this relationship, right? Which is that we know that for a capacitor, and when you connect capacitor to a voltage source, there's going to have inbuilt of charges. So you have charges mean that are proportional to the voltage supplied. Then we have charge equals capacitance and voltage. Now, if you take small amount of the charges which are already accumulated, then that will give you a very small amount of voltage. So we have the QV equals to capacitance times the V. Then we know current will be equals to the Q over the T, meaning the rate of flow of charges. So we have this, we do replacement, we get I to be equals to which is the current capacitance times dV over dt. So this is the general formula for the current passing through a capacitor. Now we come here and then we explain on that idea. So the voltage here will just be the potential difference between V in and then node voltage at node A. So we get this relationship, and that will be equals to IF to, again, using potential difference, we have VA, because the current here I is starting from what? It's origination from node A. So we have VA minus what? VO over the resistance, which is between the two voltages, which is RF that we have. And then we get this equation. We make the output voltage the standard, and that will give us this explanation, which is minus RF times capacitance, the input capacitance, then dV in over dt. So you can see here, this is what differentiating, because we have So when you are giving the input, you differentiate with respect to time, then you multiply by what the capacitance and then the feedback resistance level, because those are constant values. And that's how we refer to this as a differentiator. So you have your input is going to be differentiated with respect to time, and then you multiply by minus the RF and then C in. And that's how a differentiator operation amplifier works. See you in the next video. Bye-bye.